and then getting into a little more detail on the actual design of the systems themselves, and then wrap up with a couple of current examples of applications that we've completed, and then have some time at the end for some questions. So with that, I'll start into the introduction with a little bit of background on it's an extended aeration process for primarily domestic wastewater treatment. Fluence has over 400 installations since 1995, and the Tipton Series plants are primarily targeted at secondary treatment with a high effluent quality. We do have options for tertiary filtration if you need a more polished effluent, and we can also do nitrogen removal. Most specifically, in a lot of cases, we can do nitrification, denitrification for nitrogen removal, and also some phosphorus removal with chemical addition. In our plants, you'll see through the presentation, we have a typical flow range. We can treat from 3,000 gallons per day up to 150,000 gallons a day. And as I said, typically treating domestic wastewater with strengths in the range of, with the biochemical oxygen demand of 200 to 300 milligrams per liter, TSS similar at 200 to 300 milligrams per liter, and ammonia levels in the influent range of 30 to 50 milligrams per liter. And we can look at ranges outside of that, but we would have to carefully size and evaluate each application. And one of our typical applications is remote towns and parks. Fluence, a lot of our equipment's specialized in the decentralized wastewater treatment or service area, where in remote areas we don't have necessarily access to the infrastructure. These systems are good for providing cost-effective systems without having to build a really big network to connect to a larger collection system. So in here you can see some examples of some tanks being placed, and then also an underground example in a park in a remote area. An example of one of those applications in a remote community is Oak Creek, Missouri. This project was a 20,000 gallon a day system treating to 2020 effluent for BOD and TSS removal. It replaced a septic system that was failing, and it was also done in a very quick fashion. They needed to get it installed quickly. As you can see in the picture, it was partially buried. They backfilled around this, and then Fluence did provide installation and startup services for this application. And again, housing developments is another place where if you have a group of homes that isn't, again, near collection systems that are available, we can provide a small treatment system for some of the housing developments. You can see some of the pictures of the transportation and installation of the systems, and I'll describe some of that too as we get into the presentation here, as far as some of the things we look at when we're transporting and installing the systems. Another application that we do quite a bit of is with hotels and resorts. The pictures you see here, a lot of these are actually down in the Caribbean. And the pictures you see, a lot of the tanks are black, and traditionally a lot of the systems were done with coal tar epoxy, although we do also do Tnemic N69 epoxy paint in different colors as well. And we also can provide special marine coatings if it's near the sea where there might be some salinity concerns. Oh, I did neglect to mention, but I kind of like this picture in the upper left-hand corner, that this is an application down in the Caribbean where it was at a hotel, and they wanted to kind of hide it, so we painted the tank green, and then they planted all the vegetation around it to hide that. So it was one of the things we worked with them to provide in that installation. And then a specific example in the Westin Hotel in St. Martin. This is one of the larger systems we provide at 180,000 gallons a day. And we are treating to 10, 15 BOD and TSS effluent limits, specifically because they do reuse this wastewater for irrigation on site. And one of the other features of this application is we did provide multiple trains to allow for fluctuating flows during off season so they can shut off a drain during their non-peak times when they get lower flows. And on here, you can also see this is a tertiary filter on the end, and the effluent is disinfected with UV here prior to being sent out for reuse through irrigation. Another application where we have several installations is with military bases, both in the US and around the world. Some examples, we have a couple of installations in Afghanistan that were completed several years ago. Also, I have a couple of different projects we've done in Guantanamo Bay. One was kind of an initial installation, and then we also completed recently in 2018 an expansion of the larger system. We have a couple of smaller systems at Air Force bases in the US as well. And schools is another place where you see a lot of these plants being utilized if the school is located kind of away from or out kind of on the outskirts of a community where there's not a collection system available. Some of the challenges with a school installation is they do have the high surges that all your flows occurring during a fairly, brief 8-hour period during the day and then no flow at night. They also tend to have a little higher ammonia levels, so ammonia removal needs to be considered in those applications. And they also do only have flows or higher flows during the school year and lower flows during the non-school year. So we can provide a larger equalization basin to help manage some of those, and also some compartmentalization to adjust for seasonal flows. An example of an installation is we installed a 50,000 gallon per day system at a university in California. In this application, we had to meet 10 and 15 BOD TSS effluent along with a 2 milligram per liter nitrogen limit. And so again, with the high daily flow changes, we did provide a equalization basin size appropriately for this, and also provided nitrification, denitrification to make sure that we were meeting the ammonia limits, along with chemical addition for phosphorus removal, and also the tertiary filter to help make sure we met the 10 BOD and 15 TSS removal. And Fluence also provided installation and startup assistance on this application. So another example of installation was at an airport at Branson, Missouri, and some of these, you see the pictures here of the completed installation along with some of the installation photos. Going along here, we did provide a dual UV disinfection system here. I'll get into a little more detail about the installation, but the picture you see in the far right upper side there with the tank being placed in, the pad is there, and we have the rebar coming up, and that's actually how we typically anchor the tank to the concrete. Is it eliminates the need to accurately align anchor bolts and things like that. The rebar is then welded to the side of the tank and then painted again to repair the welds. And that's how the tank is anchored to the concrete pad. Some example site configurations you can see from some of the photos. One of the benefits is we can bury these tanks. We can also do a partial bury, or we've also installed them inside of buildings with a concrete pad around it in the building, or even just setting level on a concrete pad itself with access stairs and handrails. And now a little comparison to another Fluence product, just to give an idea of kind of some of the benefits of both. We have a Tipton package treatment plant system. We also have, in the lower right-hand picture, is our spiral treatment system. The advantage of the Tipton system is it's a robust structural tank. You can see in the pictures, it can be installed above or buried below grade. It's easy to customize the chamber volumes by just simply changing the chamber lengths, and I'll show some of how we adjust some of those based on our cross sections in the next slides. One of the benefits is we can integrate equalization and sludge holding chambers integral to the main tank, so the whole tank is the entire treatment system. And these tanks are currently built and assembled in the USA. And then for our spiral MABR systems, they're designed intentionally within a 40-foot shipping container configuration. This helps with standardized shipping and makes overseas shipping very easy. The MABR technology is very highly energy efficient and provides a compact footprint. And one of the big benefits of the MABR technology is it does do simultaneous nitrification, denitrification in the system. So it's good for meeting strict nitrogen discharge limits. So now I'll talk a little bit more about specifically with the Tipton system. I mentioned we can adjust the volumes of them by adjusting the lengths. We have 4 typical shipping cross sections that we use with over the road highway shipping in mind, very specifically with these dimensions that we use. So our smaller system, you'll see for 3,000 and 5,000 gallon a day system, we'll use an 8-foot wide by 9-foot 6 high. And typically the handrail and blower and other equipment on top is shipped separately to avoid height restrictions. And then for systems 6,000 to 15,000 gallons a day, we'll go to a 10-foot wide by 11-foot high. And the 11-foot high is very specific. We don't exceed that because going above that does restrict and require a lot more planning and adds a lot of expense to shipping because you'll need pilot cars and things like that. And this is another, actually one of the very common cross sections we use for 16,000 gallons a day up to 55,000 gallons per day. And this is, again, very specific for shipping purposes. We keep it at 11 foot, 11 inches wide. Once you hit 12 feet, again, you get into a whole nother level of shipping restrictions down the highway, and same thing with the 11 feet in height on this. And one thing to note on this cross section in particular, the previous ones I showed all ship in one single tank section. But on these systems, once we get up to above around 25,000 gallons a day, the systems get, depending on configuration, long enough where we'll have to split them into 2 sections and have them field welded together once they arrive on site. And then above the 55,000 gallon a day, when we get into that range, we start putting them side by side. You maybe saw in some of the previous pictures, there were tanks being placed side by side with openings in them that we have that create one large chamber out of the 2 chambers welded together here. So that's how we create the larger systems up to and above 150,000 gallons a day. So now a little more about the design and configuration of the Tipton plants. That we have our standard components, the manual bar screen, flow equalization chamber, and sludge holding chamber are integral with the typically 24-hour detention time in the aeration chamber. So for a 10,000 gallon a day system, we'll typically have a 10,000 gallon per day aeration, or excuse me, of a volume of 10,000 gallons in the aeration chamber. And then we typically use hopper bottom clarifiers and then chlorine disinfection. And I'll show some details on configurations of those in the next slides. But we can provide some optional components to do some different things. That the picture you see on the right here is actually a mechanical clarifier with a sludge rake and sludge drive in it. And these applications, a lot of times states and Texas in particular doesn't allow hopper bottom clarifiers above a certain flow. So we do provide this. It does add some more mechanical complexity to the system, but it is an option we provide. We also can provide UV disinfection instead of chlorine disinfection. And we can also add anoxic zones for nitrogen removal and tertiary filtration to meet more stringent BOD and TSS limits on the end. And I'll kind of describe some of those components specifically, with starting with the primary screen and going to the filter on the end. So the picture you see here is actually the manual bar screen where the influent would come in through the opening in the tank. And this screen would be raked every day to remove any of the larger screenings accumulated. We can also provide a comminutor to grind all the influent coming into the tank so we don't have any of the large pieces going through the system. or we can also, as an option, provide mechanical bar screening. And some of the details about flow equalization, this is a standard feature on our system. It's actually required for operation. We want to provide it. If we don't have it, we've seen situations where the pumping into the system can disrupt the clarifier or even the chlorine disinfection. So we very strongly encourage using an equalization to avoid that problem. It allows a consistent flow into the secondary, and a lot of those applications with schools, work camps, and housing are situations where there are frequent fluctuations in flow. And the main components will go into some of those. That we do provide duplex pumps with levels switch control. We also use an aeration blower to aerate and mix that zone. We control describe more in detail the flow proportioning box, how we control the flow going forward. And you saw in the previous picture the bar screen we provide. So on the flow proportioning box in our flow equalization, this is actually one key kind of component to the entire system that allows us to maintain the flow going forward into the aeration system or the secondary treatment system at a consistent flow level. A lot of times at these flows, we use 1/2 horsepower, small, just submersible pumps, but those usually deliver in the range of 80 gallons per minute. So if we needed to, for example, to provide a design flow of 40 gallons a minute going forward, the pumps will pump up into this box at 80 gallons a minute. The adjustable weir here on this side is set so that the flow going over the V-notch weir forward, it will be the 40 gallons a minute, and then the excess 40 gallons a minute will flow back into the equalization, and that's how we manage that difference in flow. That way we don't have to use any kind of flow metering or flow VFDs or anything on the pumps. It kind of keeps everything very economical. And in the heart of the system, the aeration chamber that we use on the system, this is where the BOD, TSS, and our ammonia reduction occurs. We use coarse bubble diffusers that are controlled through blower, and we use timer settings on the blowers for on-off cycles in the system. And as I mentioned before, it's typically a 24-hour detention time. We also evaluate the loading to keep it in 10 to 25 pounds of BOD per day per 1,000 cubic feet. And in the picture to the right, this is actually inside of a tank that was recently constructed. As I mentioned, you can see the coarse bubble diffusers down on the lower right, and they're very intentionally mounted on the one side of the tank like this. And the design intent of that is that as the aerator is running, the bubbles will rise on this side and it'll create a rolling effect in the tank to keep the tank mixed throughout, so you'll get a plug flow complete mix circulation through the aeration chamber. A little bit more detail on just kind of the process flow diagram in particular. Out of the equalization basin over here, then we go into the inlet of the aeration chamber. You can see we use the arrows to describe that plug flow circulating system complete mix. From there, that activated sludge system is sent to the hopper bottom clarifier where the solids are separated out. The effluent goes to typically a chlorine contact chamber with 30 minutes of detention. So the effluent comes out of there. The solids collected in the clarifier are typically returned mostly to the aeration chamber. And then occasionally sludge is drawn off to put into the sludge holding tank for disposal of the sludge. We also have scum control in the clarifier that's recirculated back into the treatment process as well. As I mentioned, this is an example picture of our hopper bottom clarifiers. Again, we do provide circular mechanical clarifiers as an option. But one thing that I like about this picture is it just shows a larger hopper bottom clarifier with 4 hoppers on it. But as I showed in the cross sections, we keep our height to 11 feet shipping down the road. A lot of times, especially with the larger clarifiers, we end up the hoppers being projecting down below the 11-foot height. So what we'll do is cut off the bottom of the hoppers and ship those separate. And those are installed here. And before it's set in place, those are lifted up and field welded to the bottom of the tank. So that's how we can provide a hopper bottom clarifier taller than 11 feet to meet the site needs. And this is our, going a little bit into detail, the secondary process treatment, the clarifier chamber. This is where the solids settle and separate after the aeration chamber. We do provide airlift sludge return pumps typically, and also skimmers with airlifts. The picture on the right is an example of the adjustable skimmer in action. And the tank also includes an effluent V-notch weir for effluent overflow. We also provide, for our standard is chlorine disinfection. It's a tablet hypochlorite feed system, as shown in the picture here. And again, that's typically a 30-minute detention time. And we provide baffling in this tank to make sure that all the water stays within that system for the full 30 minutes. And we can also provide tablet dechlorination as an option too, if there's effluent chlorine requirements or limits. An example of our UV disinfection that's provided as an option where the chlorine residuals aren't acceptable, or sometimes the operators don't want to deal with the chlorine tablets or the chlorine chemicals. This is a good option to provide. We can typically provide the low pressure horizontal open channel UV disinfection systems like the ones pictured. I think some of the other pictures we can hang them off the side or the end of the tank as needed for site requirements. And another option for our system, we do provide tertiary filter, both rapid sand or upflow sock filters. The graphic on the right is actually a 3D model of our rapid sand filter configuration. We typically use this if we need to meet a effluent limit of 15 milligrams per liter BOD or 15 milligrams per liter TSS. And this is a rapid sand filter design. The one you see here is actually with dual filter cells. A little more detail into the operation of the tertiary filter. There's a picture on the right here. The inlet comes in. That's what this is showing here, with a little plate to distribute the flow. And that flow goes down over through the anthracite and sand layers into a false bottom under drain. You can see the nozzles in the picture here. The media hasn't been installed in this application yet. But after going through the media in our design, it'll go back actually up through the backwash pump piping and into the clear well chamber. And this design then allows, when it's time to backwash, this diagram shows how the backwash is then flows from the backwash pump. Once the backwash pump's turned on, it actually forces flow back up through the under drain to clean the media, and it overflows into the mud well chamber, which is then pumped back to the head of the plant for further treatment. And then again, we do provide, in some applications, an optional anoxic chamber for nitrification, denitrification. And that's typically placed in front of the aeration chamber, and it's part of the secondary treatment process. Do a diagram kind of the nitrogen cycle coming in as ammonia that gets then changed to nitrite, and then finally nitrate. And then denitrification takes that nitrate back again all the way to ammonia and finally nitrogen gas through that recirculation process. So on the additional equipment that we need to provide this, we do provide a mixer in that anoxic zone to keep everything in suspension. And we do put the MLSS recirculation pumps typically around 4 times the influent flows, where we recirculate back to that anoxic zone. And we can, for applications, if we need to meet less than 10 milligrams per liter of total nitrogen, the system will perform well in those applications. And a typical example of the delivery schedule, again, this is going to vary a lot depending on the size of the plant, and we can certainly work with customers to meet their needs on these. But usually we look at about 4 weeks for submittal of drawings after we get the PO. Manufacturing of the plants usually about 10 to 12 weeks at our tank shop, and then kind of depending on within the US, usually about 1 week. If we had to ship outside, it adds several weeks to that schedule. And then we estimate typically 4 to 12 weeks of installation time on site. That includes setting the tank in place and getting all the anchors welded and connecting the effluent and influent piping and a lot of their electrical work. And we do provide startup and training, usually 1 or 2 days for equipment checkout and 2 or 3 days of operator training. Just kind of an estimated total of 20 to 35 weeks to deliver one of these plants. But again, we'll have to determine those exact applications for each specific project. A little more detail on the tank transportation. Like I said, these are designed for down the road shipping to be placed on flatbed trailers. You see the picture on the left. Some of our circular clarifiers, we have creatively cut them into sections to get them down the road within those shipping dimensions. And the important thing to note is that the blower motor and control panels and grating and handrails are all shipped on a flatbed down the road separately for installation on site. So a little more detail about the installation process. This is an example on the left-hand side of a double wide installation. This is where they'll set the tank down, and those windows there where they're welded together to create the one larger zone for aeration. You see the tank being welded here in the field, kind of the finished product there. And then these rebar, again, are, like I said, how we anchor the tanks to the concrete, and those just get welded to the side of the tank. And then we send touch-up paint along with the tanks to fix the weld spots after they're anchored to the concrete. So just a little more kind of background on the installation process. Usually we schedule a crane to set the tank in place on the day of delivery. Again, I mentioned the stairs and some of the piping and hand railing are shipped separately. As an example of a blower that would be mounted on top of the tank. So those are some of the things that the contractor we have do is to complete the installation on the concrete pad, connect the electrical power, and then we do include drain plugs along with this that need to be installed on site to make sure that the tank's going to hold the water. Otherwise, when it's shipping, we don't want that water collecting in there. And for buried installations, we do provide magnesium anode packages that will allow for corrosion control in buried applications. And Fluence does provide startup services. We can provide installation supervision, mechanical checkup for site visits, and startup services with operator training. And now look kind of some of the information we usually look if you're looking for a proposal, some of the information we need. I'd like to see a copy of the permit if we can, just so we know what treatment limits we need to meet. Project location and waste stream type, any influent parameters that we either have records of or what we're estimating for, site elevation and location. Site voltage is a very important one to make sure that we provide the right equipment, and peak hourly flow rate helps us size the equalization system properly. We need to know if it's above or below grade installation. And then if it's continual operation or seasonal, that'll help us adjust how we manage the flows during those times. And some of the design parameters and data for the Fluence side. Like I said, for typical municipal wastewater, we'll assume 240 milligrams per liter BOD or 240 milligrams per liter TSS. Assume a TKN of 50 milligrams per liter. And the design flow rate of 1 times the design flow, and then a peak flow will assume 2.5 times unless we have other data. An example, discharge limits that we design for. Typically for secondary, we expect to see 30-30 for BOD TSS with the 3 ammonia nitrogen and around 10 total nitrogen. If we're doing tertiary, then we expect 10 or 15 BOD TSS, and actually I think this 10 nitrogen should be over here with tertiary treatment. And chlorine residual, we can treat down to 0.1 and hit a fecal coliform of 200 mpn per 100 milliliters. And now I'll kind of wrap up with the last couple of example installations that we recently completed. This one here is for Gold Hill, Nevada, that was completed a couple of years ago. Some of the project highlights on this, it was domestic water for a small community. They had a failing system there. The state was requiring them to provide a higher level of treatment. It was a 10,000 gallon a day system, and it was in a mining town in Nevada, just a little east of Lake Tahoe. And they wanted to keep the kind of historic mining look of it and also keep the odors and sounds in the site, noise control in the site. So they put a building around it to kind of match the rustic look of the area. And this is a picture of our tank installed buried inside of the building. And again, we can meet 30-30 BOD TSS application. And this one did have an anoxic zone to provide nitrification, denitrification to 10 milligrams per liter TN limits. And another more recent installation, we had a client in Charleston, Tennessee, who needed a tank quickly last fall. And so we got the tank built for a commercial industrial installation in Charleston. It was a 10,000 gallon per day system. And initially we sized it for 30-30 BOD TSS and built as a standard aeration plant. Unfortunately, the engineer working on this project had been told that Tennessee has some older legislation in place that does not allow extended aeration plants in the 10,000 gallon per day range. But the engineer was told that the legislation would be changed that year and allowed in 2023 to be installed it this way. However, when we finally got it on site, we found out that the legislation wasn't changed. So for this client, we worked with them to modify the tank into a moving bed biofilm reactor system that would meet the Tennessee state requirements. So we were able to rework the tank. The picture on the right here, we added a stainless steel wall inside to provide an area for the media, and also did a lot of repiping to create the zones we needed in that tank. So with that, that completes my presentation. We can open it up for questions and conversation.
Yeah, if anybody has any questions, go ahead and put them in the chat. Or feel free to raise your hand if you'd like. So we have a question that's, what type of MBBR media does Fluence use?
So on this application, we worked with SSI to provide the media, and I actually worked with I have to give a lot of credit to my coworker, Jason Bowman, helped me source that. He had a lot of experience working with MBBRs.
Anything else from anyone? Okay, well, if we don't have anything else, we'll give you guys a little bit of your time back. Thanks for joining us today. And you can always reach out to Jeremy or to us if something else comes up.
Thank you for joining.
Thank you.
There's a couple questions popping up yet.
Are there?
Yep.
Let's see.
Fluence install systems in really cold areas.
A lot of our systems are down south and not necessarily in cold areas. We have in some places installed. I believe we have some in one in North Dakota that's inside of a building. So some of our colder applications tend to be buried or covered with the building.
So this one's it.
There's a follow-up to that about what provisions does Fluence make when really cold? And then there's another one or two below that.
As I said, now typically we'll bury the tanks in cold weather applications or put a building over it. We don't usually use, but we can include some heat tracing of pipes if needed. A lot of times the warmth of the domestic wastewater along with the building or buried tank will allow operation during cold weather.
It looks like we have another one. Can you give an estimated cost of a 10K standard extended aeration system?
Unfortunately, I don't remember off the top of my head, but we can provide that if you want to reach out with a specific application. We'd be happy to provide a budgetary cost.